Let's consider the line y equal negative 6/5 x minus 17. We're asked to do two things. We want to write an equation parallel to this given line that passes through the point negative 6, 6. And we want to write the equation of a line perpendicular to this given line that passes through the point negative 6, 6. So there are several parts, lots of parts to this problem. Before we break it down and do each of these parts, let's actually take a look at what is going on. Let's visualize the problem. So with the help of Desmos, I have a picture that shows both the line y equal negative 6/5 x minus 17 in red and the point negative 6, 6 in blue. Now, first we're asked to give the equation of a line parallel to the given line. So let's focus on that part of the problem first. So what does it mean to be parallel? Well, let's see. So I want a line that's parallel to the red line, but passes through the point negative 6, 6. Now I'm just going to eyeball it, but parallel, if I have a line parallel, that means they're going to run side by side, kind of like railroad tracks, right? They're running parallel side by side. And so as I'm running side by side, I have this line. This is the line I'm trying to find the equation of. This is what I'm looking for. I want to know what is the equation for this line. Let's start by doing that. Now, how do we find the equation of a line? There are several different ways, but one way is to use the point-slope form. That is, y minus y1 equals m times x minus x1. This is the formula that I tend to use most often when writing the equation for a line. In this formula, there are two things that we need in order to write the equation. We need m, which is our slope, and we need the values x1 and y1. And those stand for a point on the line, right? All right. Well, what do I have for this first part? I'm asked to give the equation of a line parallel. So what do I know about this line? Well, I do know that this line passes through a point negative 6, 6. And therefore, I do know that my x1 value is negative 6 and my y1 value is 6, right? That's the point. How about the slope? What do I know about the slope? So we have our point, we need our slope. Well, the slope comes from the fact that we have a line parallel to a given line. That is, if I can find the line of my first slope, if I can find the slope of my first line, then I'll be able to find the slope of my second line. So let's refer back to our red line. My slope is the same as the red line, so my slope is negative 6/5. This information together, combined with the point-slope formula, will actually give us the equation for our green line. So in place of y1, I'm putting 6. In place of m, I'm putting negative 6/5. And in place of x1, I'm going to put negative 6. There's a lot of 6's in this problem. Let's clean this up a little bit. That's y minus 6 equals negative 6/5 times x plus 6. Let's continue to clean this up. We're going to distribute, so we're going to take negative 6/5 and multiply it through. That's going to give us y minus 6 equals negative 6/5 times x plus negative 6/5 times 6, which I'm going to write as 6 over 1. Now, when we multiply fractions, how do we do that? We multiply by multiplying numerators and multiplying denominators. So really, this is just y minus 6 equals negative 6/5 x minus 36, because negative 6 times 6 is negative 36 over 5 times 1, which is 5. All right, we're almost done. The last thing we have to do to isolate for y is we need to add 6 to both sides of our equation. Now on the left side, it's easy. The negative 6 and positive 6 cancel out. But on the right side, I have to do a little bit of work. That's because I have a fraction being added to an integer value. So let me go here to the side, and I'm going to put negative 36 fifths. And I'm going to add to that the integer 6, which I'm going to write as 6 over 1. In order to combine fractions, we need a common denominator. That means I'm going to need to multiply numerator and denominator here on the second fraction by 5. So that gives us negative 36 fifths plus 30 over 5. I now have common denominators, so I add my numerators. Negative 36 plus 30 is just negative 6 fifths. Oh my goodness, there's a little bit too many 6s and 5s all over the place. But that tells me that my final answer is just y equals negative 6 fifths x minus 6 fifths. This is the equation of that green line right there that is parallel to the red line, the one given. So that means my equation for this line is y equals negative 6 fifths x minus 6 fifths. This is the equation for the green line parallel to the given red line. Let's start fresh on a new page to do the second part of this problem. And the second part of this problem is, instead of finding a line that's parallel, we want to find a line perpendicular. So now, continuing on, we are going to find the line perpendicular to the given line, passing through the point negative 6, 6. So again, we're going to be passing through the point negative 6, 6, but this time we want to be perpendicular. And what does that mean, to be perpendicular? To be perpendicular means to meet at right angles, perfectly right angles. So these two lines have 90 degrees in between them. So the question is, what is the equation for this line? Well, we can repeat the same process we did for the other line, meaning we can start by looking at the point-slope form, which is y minus y1 equals m times x minus x1, and recognizing that we need the parts m, slope, and we need a point x1, y1. The nice thing is we're actually given that point, right? Negative 6, 6 that falls on this line. So we're given a point. So we know that our x1, y1 can be represented by the point negative 6, 6. So the only thing missing in order to write the equation for this green line is the slope. But the cool thing is, what do we know about lines that are perpendicular to each other? If you have two lines that are perpendicular to each other, what can we say about the slopes of those lines? The slopes are not the same. What are they? They're called negative reciprocals. So the slopes of two perpendicular lines are negative reciprocals. That means when you multiply them, they give you negative 1. Or if you like, they're the multiplicative inverses with a negative in front. All right, so what does that really mean? All these big fancy words. Okay, so we know our original line that's red had a slope and has a slope that's equal to negative 6 fifths. So if I want to find the slope of the green line, I'm looking for the slope that's perpendicular to negative 6 fifths. So I'm going to take the negative reciprocal. That means I'm going to invert the negative 6 fifths, and instead of being a negative, I'm going to make it positive. This is the negative reciprocal of negative 6 fifths. That is 5 sixths. I have all the pieces I need to put this problem together. I'm now going to plug things into my formula and solve. So we have y minus y1, which is 6, equals m, which is 5 sixths, times x minus x1, which is negative 6. I'm going to clean this up, and I'm going to clean this up by using the distributive property. That's going to give us y minus 6 equals 5 sixths x. Oh, I did a little quick step here, but negative negative, just to remind ourselves, a negative negative is actually a positive. So I'm taking 5/6 times positive 6, right? So that's 5/6 times a positive 6 over 1. There was a little side note here that I didn't write down, but y minus 6 equals 5/6 times x plus 6 is what I have when I have the double negative. And so then when I distribute, I have 5, just to clarify, we had 5/6 times x and 5/6 times 6. So that's where I got this line from. Continuing on, I have y minus 6 equals 5/6x. And what I'm going to do is I'm just going to do a straight quick cancellation because I see I have a 6 in my numerator and my denominator. And that tells me I have 5 times 1 on top, which is just 5. And 1 times 1 on the bottom, which is just 1. So I really just have 5 over 1 there. I have y minus 6 equals 5/6x plus 5. And my last step is to isolate for y, so I'm going to add 6 to both sides. And so that tells me that I have y equal 5/6x plus 11. That is the equation of the line that's perpendicular to the given line. Y equal 5/6x plus 11. And that completes our problem. We have found lines both parallel and perpendicular to a given line passing through the point -6, 6.